All right, let's take a look at calculating impulse, or again, the change in momentum of various objects when there is a change in direction. This is something that students commonly struggle with, and I want to make a note of it, that you should be aware of the sign of velocity when you're calculating change in momentums or impulses. And this is nothing new, but I'd like to spend some time on it and make sure that you feel comfortable with this before moving on. Let's calculate the change in momentum for each of these four scenarios, A, B, C, and D. In each of those scenarios, a cart with a spring plunger is colliding with a wall, and we're given the initial and final velocities of the cart as well as the mass of each cart. Before proceeding, I would like you to pause the video and attempt each of these problems for yourself. See if you can calculate the change in momentum of the cart before and after the collision. I'd like to recall the momentum tables that we used when solving problems involving collisions. I've included one down below for reference. Notice that in this table, we had a box for momentum change. Well, now we can just call that impulse, right? We know that the change in momentum of that object is also called delta P, right? That's our impulse. So we've actually been calculating impulse this whole time. We just didn't have a name for it. So I'd like you to use this momentum table and attempt to calculate the impulse or change in momentum of each of these carts before and after the collision. Pause the video, attempt to solve these for yourself, and come back when you're finished. All right, now that you've had a moment to try these on your own, for A, we see that before the collision, the mass of the car is 10 kilograms and the initial velocity is 4 meters per second to the right. So this is going to be a positive 4 meters per second. So that means that the momentum of the car before the collision will be 4 times 10. That'll be 40, and the units are kilogram times meter over second. The momentum after the collision, since the car has a final velocity of 0, we know will just be 10 times 0, in other words, 0 kilogram meter seconds. And so we know if the car had a positive 40 units of momentum before and they have 0 now, then the car must have lost or minus 40 units of momentum here. All right, so this would be a negative change because I had positive momentum before and now I have a less positive or 0 momentum in this case. So I've lost, in other words, 40 units of momentum. Now, keep in mind, this car is experiencing an external force. And so previously, when we solved problems involving collisions, we were looking at systems where there were no external forces. And so for these problems, the momentum of that object is going to change. If we included that wall in our system, we would see that the momentum of the system would not change. But we can't easily quantify the microscopic motions of that wall. And so we're dealing with problems involving external forces now. So the change in momentum of that car does not have to be 0. It's going to have some non-zero change because it's experiencing an external force from the wall. All right, let's take a look at B. For situation B, the initial momentum of the car will be the mass 10 multiplied by 3 meters per second. So that'll be 30 units of momentum. And then after the collision, right, you might not always be told here that the car is moving backwards, but if it's just reported at a velocity of 1 meter per second, you have to be careful to supply that negative. Okay, so make sure that you understand that when an object changes directions, the sign of its velocity changes as well, even if you're not necessarily given the negative sign in the problem statement. If it just said, well, the car is moving 1 meter per second to the left, you have to interpret to the left as negative. So be careful of your sign when you're solving impulse problems. In this case, that would be 10 multiplied by a velocity of -1, and that would be -10 units of momentum. And so if I had 30 positive before, and now I have -10, then the change in momentum here would be -40 units of momentum. And I wouldn't necessarily say that the momentum here has decreased. It's just become more negative. Remember, in this class, negative signs indicate direction, not necessarily absolute value. And so the momentum here is now more negative than it was before. If we look at the absolute values of the momentums before and after the collision, we see that it's only 10 units after the collision, and it was 30 before. And so we see here that the car has overall less momentum after the collision than it did before, but we would have to compare the absolute value of momentum to say something about that. All we know from the change is that my momentum is more negative now. All right, let's take a look at situation C. All right, the momentum of that car before would be 20, a positive 20 units of momentum, 10 times 2. That'd be positive 20. I'll show the positive sign. And after the collision, that would be 10 times negative 2 in this case, so negative 20 units of momentum. Again, making sure that when you see it moving to the left, you supply that negative sign, even if it's not given. This means that the change in momentum of that car will be negative 40 units of momentum as well. All right, let's take a look at D. All right, so for D, before the collision, I will have 5 times 5 units, so that'll be 25 units of momentum. And after the collision, I will have 5 times, it's moving to the left now, so left negative 3 meters per second, so that would be negative 15 kilogram times meter per second. So the overall change in my momentum from 25 all the way to negative 15 would be a change of, as you might have guessed, negative 40 units once again. And so it turns out that the change in momentum, or the impulse, for each of these scenarios was the same. There are many different ways to have the same change in momentum, and the purpose of this activity was to be very mindful of the sign of our velocity before and after the collision. All right, let's take a look at some more examples.